Hey guys. In NATS JetStream, typically every message in a stream expires at the same time. There's kind of one rule. But what if a session token needs 5 seconds and an order needs an hour? What if every message could decide when it dies? This is per message TTL, and it was added in NATS 2.11. It lets every message in a JetStream stream carry its own expiration. In this video, I'll break down how it works and demo it live. Let's get into it. Before we get into it, let's quickly break down how per message TTL actually works under the hood.
NATS per message TTLs. It's fine-grained expiration for your JetStream messages. Messages don't all age the same. By default, a JetStream stream gives you one expiration rule, MaxAge, and it applies to every message equally. A session token, an order event, a cache entry, they all expire at the same time. One expiration rule for all messages. With per message TTLs, you can give each message its own expiration. Now you can set a TTL on individual messages using the Nats-TTL header. A session token can expire in 5 seconds, a cache entry in 30 seconds. An order event can stick around for an hour. Each message carries its own lifetime. Set expiration per message with the Nats-TTL header. Enable it in your stream config by setting allow_message_TTL to true. Once enabled, each message's TTL countdown runs independently. MaxAge still applies as an upper bound. A message's TTL can't exceed it. This is perfect for something like session state. You can auto-expire sessions without cleanup jobs. Distributed caching. It allows you to cache entries with natural TTLs. KV buckets. You can have per key TTL with automatic delete markers. So now there's no manual cleanup, no cron jobs. Messages expire automatically. So this is really cool stuff. Let's see it in action.
All right, let's do a quick demo. First things first, we have JetStream already started. So here's what we're going to do. We're going to create a quick stream with memory storage, and we're going to set a limits retention policy with a max age of 1 minute. And the key field here is allow message TTL, which will allow us to apply our per message TTL. The next thing we're going to do is we're going to use the watched command to watch this stream. Then we're going to publish 3 messages to the stream. We're going to use the Nats-TTL header, and the first message will have a 5-second TTL. The second will be 15 seconds, and for the third, we won't provide a TTL. We'll use the max age for the stream. Last but not least, we'll send a message in with a Nats-TTL of never, so it never expires. It will outlive the max age for the stream. So let's go ahead and create the stream real quick. I'll just copy this. And if we zoom in at the output, we can see it allows per message TTL. All right, let's copy our watch command to watch our stream. And now let's copy some messages and watch the clock. And remember, the first message is 5 seconds, the second one is 15, and the third one is max age, which is 20 seconds. You can see we have 3 messages there, and the clock has started, and pretty soon there will be 2. There we go. And now in 10 more seconds, there should be 1. You can just watch the clock and count it down. There we go. And now in 5 more seconds, we should have 0. And there you go. All the messages are gone, all on their own TTLs. Now let's make our message with a TTL of never, so it never expires and survives the max age. So we're going to copy this, and then we're going to sit for about 20 seconds. And we're going to start at 9:27. So we'll just sit here for a minute, and hopefully we don't fall asleep. We're going to wait for around 9:47, so 8 more seconds. Just try not to pretend you're counting sheep. And if you're still awake, you can see that the message is still there and it's being retained after the max age. Let's just take a look at the stream right now and see what it looks like. We're going to run NATS stream view and just take a look. And there's our message, still there, NATS TTL never, and we're keeping it forever. So I'd mentioned this is useful for KV stores. Let's check that out. All right, let's look at this little program I threw together. This is going to show us how we can use TTLs on keys within a bucket. First, we're just going to show a bucket-wide TTL. All of the keys will be deleted at the same time. And then we'll show a per key TTL, where they're all removed individually on their own timers. So what are we doing here? First, we connect to NATS. Then we're going to create a bucket with a TTL of 10 seconds. Then we'll create 3 keys. They won't have their own TTLs. They'll just use the bucket's TTL. And then we're going to pull our bucket status just to watch these 3. And down here is something similar. We're going to create another bucket. And this is important. Notice the field limit marker TTL. This enables us to do per key TTL on this bucket. With the KV store, when a key expires or is deleted, NATS doesn't immediately remove the entry. Instead, it places a delete marker, or a tombstone, to signal to watchers and subscribers that the data is gone. The limit marker TTL determines how long this delete marker persists. Once the marker itself expires, the key is fully purged from the system. So we're setting it to 1 second, so the keys are purged immediately. And next, we create 3 keys, but each of these have their own TTLs. One for 5 seconds, one for 10 seconds, and one for 15 seconds. And then we're going to watch this bucket, and we're going to watch as these keys are deleted. And at the very end, we're going to print the status of the bucket. We're keeping it simple. Let's check it out. So I'll start the program, and you're going to see it just continuously loop. We're just going to keep pulling and checking on the bucket. And these keys do not have individual TTLs. They're all going to expire at 10 seconds at the same time. And now each key will have a TTL, and they'll expire individually. There goes 1. And 2. And 3. They're all gone. And there's 0 keys remaining. So I'm sure you could see how this could be incredibly useful, and it's so easy. It just does it for you. And that's per message TTL. No cron jobs, no cleanup logic. Just set a header and let NATS basically handle the rest. If you found this useful, drop a like and subscribe for more NATS content, and I'll see you in the next video.